Welcome, everyone. I'm Rosemary Bartlett with the Pacific Northwest National Laboratory, and I'd like to welcome you to today's Energy Code Commentator webinar, what you need to know about the new energy standard for commercial buildings, Standard 90.1 2019. Our speakers today are Drake Irby, Len Shera, Jeff Bolt, Michael Meyer presenting for Kelly Seeger, Michael Rosenberg, and Reed Hart. Welcome to all the speakers and welcome again to all of you.
As chair of the standard, it is my pleasure to begin the presentation of the 2019 version of 90.1 with a chair's overview of its goals and results. Goal 1 and primary objective is to publish a consensus minimum requirement standard that saves energy, is technically feasible, and cost effective. Compliance is necessary in order to deliver the energy savings resulting in each version of the standard. Therefore, clarity leading to understanding of the standard is necessary to achieve compliance. During the 2013 cycle, it was determined that it is necessary to look further out than 3 years if the standard is going to remain viable moving into the future. To do that, a real understanding of the changing built environment landscape is required, and a working group dedicated to that was formed to advise on areas that should be pursued. It should be noted, in addition to publication of the standard, there will be a Department of Energy determination of both energy and cost effectiveness, and it will be performed in the near future to establish this version as the standard of care. Under Goal 2, compliance, significant effort was made this cycle to look at the entire standard and to improve clarity. Submittal documentation was enhanced, definitions and references were analyzed and either improved or deleted if not necessary. Additions and alterations is an area that has not been as clear as it could be and has led to some confusion in the past. This has been addressed in all sections, but especially Section 4, since its responsibility is compliance. In order for a building to operate as designed, it must be commissioned. For the first time, a cross-cutting work group was formed to take a hard look at this area, and I am happy to say we're successful, as you will see further in this presentation. On the goal of viability and strategic direction, 2 areas were identified that will affect the standard's viability, so cross-cutting work groups were formed to look at widening title, purpose, and scope to include site and inclusion of renewables into the standard. Their efforts resulted in addenda out for public review and will continue as well into the next cycle. As chair, I would like to thank PNNL, the Department of Energy, and all of the volunteers, commenters, and ASHRAE staff for their support in the publication of ASHRAE Standard 90.1 2019.
Hi, so my name is Len Shera, and I'm an architect, and I'm the chair of the Envelope Subcommittee, and this part of the seminar is going to cover the envelope portions of 90.1, otherwise known as Chapter 5. So there were 3 types of changes that were made, and they kind of been grouped in these categories of cleanup type changes. That were fixing mistakes. There were some criteria changes, and then there are what I call text rearrangement type changes. And I'm just showing this graphic of, this is a typical 90.1 building that was designed in the 70s that sort of is supposed to represent all of the buildings that we build now in the different space conditioning categories. So just a real quick refresher. As you know from the other parts of the seminar and the history of 90.1 that there are different chapters. Chapter 5 is envelope, and then there's a flow chart that sort of goes through all the subsections. And then within each chapter, there's the multiple compliance paths. Within Chapter 5, there's a prescriptive path. There's a trade-off path that is typically known as ComCheck. There's Section 11, which is a code-compliant type of energy modeling trade-off, and then Appendix G, which is a little bit more flexible performance modeling trade-off. They're all acceptable to Chapter 5, and when they go over the appendixes, they'll talk about the specifics, but in general, you can use all of those to comply with Chapter 5. The important thing to note, we're going to talk about later, is that there was some changes with 5.7, 5.8, and 5.9 in terms of compliance that relate to commissioning. And I believe on another part of the seminar, there's a discussion about commissioning and how that relates to the overall standard. Okay, so in terms of the updates, we did some definition changes. We talked about there was a change to the Cool Roof Rating Council standard. So if you're doing specs, that's important to note. We added some clarification for rooftop monitors, and the word operable will become a little bit more nuanced when we get into the fenestration criteria. And then we did a lot with doors in terms of clarifying what a door is versus a revolving door versus an overhead door. So they're not stringency requirements, but depending on if you do work for a door manufacturer, they may impact you. So it is important to sort of understand from a general architecture point of view, it's probably not that much more stringent, but from a very specific door assembly, some of these may come to play. And so just be aware of that depending on sort of where you're coming from. Okay, so let's get to the meat of the changes. On the criteria changes, the real big changes were in the windows. And there were two big changes that happened. There were criteria changes, the actual SHGC and U-factor values, and there were category changes. So the way 90.1 is structured, if you guys remember, there's a table, and then within that table there's a fenestration, like a subtable for fenestration. And before, the fenestration was broken out into non-metal framing and metal framing, and then within metal framing there was fixed, operable, and entrance. So we have combined that to make it material neutral. So now a metal window is compared to a vinyl window, which is compared to a wood window. And we've broken it out into how those windows operate, fixed, operable, and then an entrance door. And remember, we talked about doors before, and so entrance door comes into that as a door that's more than 25% glazed. So within those fixed and operable categories now, we have criteria, and primarily that's because an operating type window typically has a heavier frame, and so the criteria tend to be a little bit more relaxed versus a fixed window, just because it has to handle all the geometry of the operating. So your curtain walls would fall under fixed, and punched windows, if it's a casement, would fall under fixed, and that, a picture window, if it's a casement or double hung, whether it's metal or aluminum or wood, would all fall under operable. So that's like the first big thing to note on in the 2019 changes. Okay, the more significant change to the envelope was the criteria for the actual values. And within 90.1, there's an SHGC requirement, which is a sort of a heat gain, heat reduction strategy, and there's a U-factor requirement, which is a thermal transmission requirement. So the material neutrality didn't really affect the SHGC. That is just a factor of better glass technology being more cost effective, and so across the board, SHGC has gotten a little bit better. Except for Climate Zone 0, which is the kind of the really hot. It's either, depending on A or B, you're either in like the Middle East or you're in Hawaii. So for U-factor, that's where the material neutrality really did come into play, and the changes here I'm showing are for metal framing fixed. So you'll notice they all have gotten a little bit more stringent. Again, for the U-factor, lower number is better, higher number is more transmissive, and so all of the metal frames have gotten, or the metal frames have gotten more stringent. However, if you are a non-metallic frame, you may see a decrease in stringency. So it's important to note what type of window you're using now. The code may be more stringent or less stringent, sort of depending upon your point of view. We're still limited to 40% window wall ratio within the compliance path here. But that window type will drive a lot of your energy use, and is a part of the trade-off that you use for Chapter 11, even 5.6 ComCheck and Appendix G. Okay, The other criteria change is really more of an exception. It was related to the vestibule requirement, which primarily says all buildings should have either a revolving door or a vestibule. And then there were exceptions for small buildings, warm climates, semi-heated buildings. We've added an air curtain allowance that allows you to install an air curtain to a self-closing door. And there's two categories. There's the warmer climates and there's colder climates. The warmer climates, and 1 and 2 are not, it's not a typo, it is really 0, 3, and 4. That building size is not limited. In the colder climates, 5 through 8, 15 stories or less to avoid the stack effect, where the air curtains don't really work. They can't overcome that stack effect. And basically, you can install an air curtain on these automatic doors. You have to, as you're writing your spec requirements, make sure there's ANSI requirements, jet velocity, angles, and they have to be commissioned, and there's control requirements that are in Chapter 10. So just to make sure when you're installing these things that they do relate to your other disciplines, it's not just a matter of buying an air curtain and sticking it on a door. Okay, the last section was text rearrangements, and there's two things that happened here. One was on air leakage, one was on inspections. So before, air leakage was very simply a material requirement or an assembly requirement or a building testing requirement, and you sort of went in that order because that's the way we as architects were thinking about pieces. Small pieces had a very tight test requirement, a piece of drywall, an air barrier. You join that piece with other pieces to make assemblies, and we know that there are some joints and some leaks, so they got more relaxed. And then when you join those assemblies into buildings, you get more leaks. And so we sort of came up with the 0.004, 0.04, 0.4, and then there's an exception that brings you back to 0.6. So that's all still in there. It's just rearranged a little bit to align a little bit more with the commissioning requirements and the idea that a whole building air test really is the gold standard for a high-performance building. So the charging paragraph now is the 0.04 with the exception for the 0.6. And the exception is the material and assembly compliance. So when you're reading this, it's encouraging to do the whole building or portions of buildings, but you always have the exception to do the inspections and testing and compliance, which then references 5.7, 5.8, and 5.9, where all the product requirements are, the material requirements for air leakage. All the stuff that used to be in the air leakage section is now in the product section where it appropriately belongs because it's a product-specific requirement. And then 5.9 we'll talk about in a second. That's the inspection piece. So 5.9 got rewritten to align with the commissioning piece as well. It used to be just two sections, verification and inspections, and now it's verification, testing, commissioning, and inspections. And you'll see this similar parallel structure in all the sections of 5.9.1, 5.9.2, 5.9.3 that deal with verification, commissioning, and inspections. Now the envelope does not have any what we would call envelope commissioning requirements. Like if anyone has worked on a sort of a high-performance building, you'll note that sometimes there's an envelope commissioning specification section or there's an envelope commissioning agent. This 90.1 merely requires verification and inspections. We have the commissioning piece in there sort of as a sort of a placeholder, but the requirements are really in the verification and inspection, which means we do want you to inspect your building, both for air leakage and for insulation placement, that all aligns with traditional building code, inspections. So that's kind of it for 90.1 envelope, and on to mechanical. Thanks.
Thank you. I'll be giving a brief overview of the mechanical changes in 90.1 2019. I'd like to start with a big shout out to the 90.1 committee, and especially the 90.1 mechanical subcommittee, many of whom you see pictured here, starting dinner and continuing to discuss how to save energy in buildings. Several vendors provided images in this PowerPoint and are acknowledged on this slide. One of the major revisions in ASHRAE 90.1 2019 is wording that allows ANSI, ASHRAE Standard 90.4, Energy Standard for Data Centers, to be used in lieu of Standard 90.1 for significant data centers. The wording took years to finalize, but essentially puts large data centers under the purview of 90.4 and small computer rooms inside of buildings under the purview of 90.1. This involved creating a definition for a computer room. Fundamentally, 90.4 has more electrical efficiency requirements, such as power supply efficiency minimums, while 90.1 has more HVAC efficiency requirements for buildings. It was important for us to avoid definitions that would allow a small computer room in a large building to cause that building to fall under 90.4 and thus bypass many HVAC requirements in 90.1. The definition of a computer room is a space having greater than 20 watts per square foot of computer or IT equipment load and a total equipment load of over 10 kW. Fan Energy Index, FEI, replaced Fan Energy Grade, FEG, in 90.1 2019. In my opinion, FEI is a much better metric for saving fan energy. FEG mainly required good fan peak efficiency. FEI, by contrast, is all about the actual selection having good wire-to-air efficiency. Basically, the kW input must be below a calculated value at the scheduled operating point. High FEI numbers indicate better efficiency for the actual selection, which is somewhat different than DOE's Pump Energy Index, which we'll talk about later. To achieve this, the fan still must be reasonably efficient. The images on the right demonstrate how a fan with high efficiency, the upper image, can have a much wider bubble of acceptable efficiencies than a less efficient fan in the lower image, which has a smaller bubble of places where you can apply that fan. The result of the FEI requirement is that some fans must be selected with larger wheel diameters than might sometimes be done in order to get the cheapest fan you can buy for that application. I believe this is good because I see far more undersized fans scheduled than I see fans that are not efficient at any point on their curves. This probably has the biggest economic impact on return fans in packaged air handling units because the casing sizes can be forced to become larger. And you may have to pick a larger diameter return fan and thus cause the casing to increase in size. So, data from a full year of production by one manufacturer showed selections made as low as 9% static efficiency. I've personally only seen them down to 19%, but apparently people do really undersized fans in some instances. So in my opinion, FEI will save significant energy in HVAC systems. There are exceptions to the FEI requirement for embedded fans, where the energy of the fan is already included in the product's total energy efficiency rating. You may see this in rooftop units. And for safety fans, for example, vehicle tunnel smoke exhaust systems. The threshold for the FEI requirement was also lowered from 5 horsepower to 1 horsepower, and more types of fans, for example, powered roof ventilators, are now covered. So I believe there are significant energy savings in the inclusion of FEI. FEI is a true wire-to-air energy measurement index. FEI is the ratio of a calculated reference input power to the actual fan input power for the selection. The basic requirements are that either for constant speed systems, the FEI must be at least 1.0, higher numbers are better, or for variable speed systems, FEI must be at least 0.95. Many equipment tables were updated. Dick Lord did amazing work to try to cover all of these. Many of these were in response to DOE updates so that 90.1 lists the same numbers as DOE does in the federal regulations. One of these updates was the Pump Efficiency Index, which is an appliance efficiency standard that prohibits the sale of pumps below a minimum peak efficiency level in the USA. We will come back to that in a later slide. Ceiling fans have new requirements in 90.1 2019. Basically, ceiling fans with blade tip diameters of at least 84.5 inches must be rated per DOE 10 CFR 430 Appendix U or AMCA Standard 230. The fan literature must report the blade tip diameter and the rated airflow and power at maximum speed. This does not require a maximum efficiency, simply clear reporting of the actual fan efficiency. It does require a standardized rating system to help make manufacturers' claims comparable. Smaller ceiling fans are covered in the Energy Star program. Energy recovery ventilators are now required in non-transient dwelling units. This primarily affects apartment and condominium complexes that are at least 4 stories tall. The requirement is for enthalpy recovery of at least 50% at the design cooling condition and at least 60% at the design heating condition. In some climate zones, both heating and cooling may not be required, so only one of the two requirements would apply. There are exceptions based on the climate zone and system size. There are updates in 90.1 2019 to the exceptions to exhaust air energy recovery. A definition of series energy recovery replaced the former use of the term energy recovery in series with the coil in the text of 90.1. A performance requirement for series energy recovery was added. This requirement is limited to climate zones 0 through 4, so your humid climates or your hot climates. Parts of this addendum were not included in the first printing of 90.1 2019 and will be corrected through the addendum process. Occupied standby is defined as when a zone is scheduled to be occupied and an occupant sensor indicates that no occupants are within the zone. This requirement is closely linked to the lighting controls in section 9.4.1.1. Standard 62.1 2016 was amended to allow zero ventilation in unoccupied zones that are scheduled to be occupied. An example is if your office area is scheduled as occupied, but you are not in the office today, not providing ventilation air is now permitted under 62.1 and required under 90.1. When zones are unoccupied, airflow is permitted to those zones only when the zone temperature varies outside of the temperature limits. I believe this will be a significant energy savings because unoccupied spaces in buildings no longer require a minimum ventilation CFM and typically the required reheat that goes with that. Standard 90.1 now has a requirement for energy recovery chillers for some hospitals. The minimum capacity is at least 7% of the design cooling capacity. This does not include backup chillers into the design capacity. I have typically seen paybacks of around 4 years for properly sized energy recovery systems of this type for hospitals. Tim Peglow did much of the analysis to show the economics, and he employs energy recovery chillers in his facilities and has seen good paybacks also. This requirement is limited to acute inpatient hospitals, those with 24-hour operation, those that have a chilled water capacity at design conditions of over 300 tons, and that have simultaneous heating and cooling when the outside air temperature is above 60 degrees Fahrenheit. There are some exceptions, including when at least 60% of the reheat energy comes from on-site renewables or site recovered energy. Climate zones 5C, 6B, 7, and 8, where the economics didn't play out to be favorable. Several types of chillers today can be used in this service, including scroll chillers, screw, or you may call them rotary helical chillers, and centrifugal multi-stage chillers. I mentioned earlier that many of the equipment efficiency tables were updated to comply with the latest DOE standards. Dick Lord and Steve Rosenstock did the lion's share of these updates, and I thank them heartily for doing all that hard work. Okay, I'm going to go through some miscellaneous changes to 90.1 2019. We removed 10 unused definitions. Yes, we actually made 90.1 smaller. The test conditions for pool dehumidifiers were updated to ASHRAE Standard 910 for moisture removal efficiency, which measures how efficiently it takes out humidity or moisture as opposed to the sensible cooling efficiency. Air barrier and envelope leakage testing requirements were updated. This is really not a mechanical item. Len will discuss it more in detail in the envelope section, but I want to point out to the HVAC engineers in our audience that this is very important for your load calculations. When you make load calculations, or at least when I do, there are two major guesses, I don't know what to call them other than guesses, that every engineer or designer must make. How much infiltration should I include in the loads? And what should I estimate for internal heat gains? On the internal heat gains topic, ASHRAE RP 1742 reported a range of 0.3 to 1.53 watts per square foot. So that's a little bit thumb in the air when you make that estimate, and you have to think about it quite a bit. I watch all the ASHRAE winter and annual meeting seminars, and if you have access to them, the winter seminar from 2019, seminar 52.1, covers interior heat gains from equipment quite well. So back to the issue of infiltration. I live in Wisconsin, and for zone heating loads, the infiltration guesstimate that I make often doubles the zone heating capacity, not the block heating capacity. I typically divide that by 2, figuring the wind only blows in one direction at a time. But the more that the building codes can control infiltration, the lower the size and cost of heating systems will become, and you as an engineer can have some confidence that the building was only supposed to leak so much. The limits that we passed in 90.1 2019 are not super strict, but I believe that as more buildings are tested, that those requirements may become more strict and maybe help lower our loads even further. Also, a lot of wording was clarified throughout 90.1 2019. I think Format and Compliance did a lot of work on that, and you'll hear about that in a later presentation. Some additional miscellaneous changes to 90.1 2019. A requirement was added for indoor pool dehumidifier energy recovery and the efficiency of that energy recovery. Basically, energy recovery equipment efficiency must be at least 50% air sensible recovery, or there must either be condenser pool heating or 50% exhaust air enthalpy recovery. Another change is that air curtains are now acceptable in lieu of vestibules in some situations. Len will speak to this in more detail in the envelope presentation. This isn't really a mechanical item, but for the HVAC engineer, this means that you may want to revise your assumptions about infiltration into lobbies. Since you probably will be asked to specify the air curtains, this also means that you should update your master specifications or schedules to include the performance requirements of 90.1/2019 for air curtains that are used in lieu of vestibules. The research that we reviewed showed that poorly adjusted or poorly selected air curtains can be ineffective or perhaps even counterproductive. So it is important that you update your specifications appropriately. I'm very interested to see how this affects lobby heating loads in the cold climate in which I live. The research presented to the 90.1 committee seems to me to be quite solid, and I'm looking forward to seeing results from buildings that we design. A third change is that electric motor selections were simplified and made to accommodate electronically commutated motors and other motors that are not rated in brake horsepower as our previous language referenced. One final miscellaneous item is that Standard 90.1 is starting to incorporate some of the recommendations of Guideline 36, high performance sequences of operation for HVAC systems, especially in the reheat and supplier temperature reset sequences. Steve Taylor, who is also a 90.1 mechanical subcommittee member and full committee member, is leading the Guideline 36 committee, and I'm sure he would be very interested in any suggestions you have for those standardized high performance control sequences. This is my last slide. I'd just like to let you know the 90.1 committee is always open to ideas that will save energy economically. If you have ideas, please contact me or any member of the 90.1 committee. Or you could stop in and attend a meeting in Orlando, or maybe attend one of the monthly web meetings. All of our meetings are announced in the ASHRAE listserv. Who knows, maybe you could become a future member of Standard 90.1. Thank you for your attention.
I'm Michael Meyer with Pacific Northwest National Laboratory. I'm a member of the Lighting Subcommittee, and I will be discussing the lighting updates in ANSI ASHRAE IES Standard 90 2019. Just a quick overview about the standard, specifically the lighting section, scope and application. It applies to lighting that is powered by a building's electrical service and can include lighting in the buildings, mounted to the exterior buildings, as well as on building sites, such as the parking lot, plazas adjacent to the building, and so on. Non-residential buildings greater than 3 stories. It includes multi-family residential buildings as well. It applies to new construction, major renovation, tenant fit-outs of existing buildings, addition to buildings, and retrofits of an existing lighting system. A retrofit is when any more than 20% of the connected load is modified. It prescribes limits in installed power, which is represented in watts per square foot, also known as a lighting power density. It mandates functional requirements for lighting controls. Also, it has requirements that vary by application. For instance, offices and retail sales area have different lighting control requirements than maybe, say, a warehouse. There are mandatory provisions. There are prescribed limits for lighting power. Those are defined by both the building area method and/or the space-by-space method. Those are two compliance options. There are lighting control requirements. They might be local control, dimming control, daylight control, power reduction, or parking lot lighting, luminary lighting control. Those are in the two main mandatory provisions through the building area method or the space-by-space method. We introduced a simplified method for lighting, which will be discussed later, which kind of tries to touch on both of those in an easier way. There is also Section 8, which has electric power requirements, which includes automatic receptacle control, deals with voltage, also has to deal with metering and monitoring and reporting. This is an agenda for what I will present today. I will first touch on the updated lighting model. We'll discuss the updated lighting power density allowances, the new simplified lighting method, and then really move into the other updates in the wattages, the parking garage, some daylighting, as well as some non-typical exterior spaces. Over on the right, you will see the sections of ASHRAE Standard 90.1 2019, where these applicable changes and updates can be found. So the first major thing to know is that the 90.1 lighting methodology, the model, was evaluated and was reconstructed. It is now representative of more real-world conditions. We went through IES recommendations. IES is the Illuminating Engineering Society, and they are a co-signatory and developer of the standard. We went through every document we could find, and whenever there was a change or an update, we made that and reflected that in our model for each of the applicable space types. We also analyzed and reanalyzed room geometry, which is expressed in a room cavity ratio, and we corrected where it needed to be corrected. Also, we reviewed light loss vectors and efficacy values. In terms of efficacy, this is the efficiency of the light fixture. We reviewed many manufacturers as well as multiple products within even a manufacturer line, and updated all of our data points to reflect current trends and data points on efficacy. We also referenced commercial programs and installed typical values to get a sense of where they were going. We also added an additional surface reflectance category to reflect more changes and be consistent with other programs. The new model now uses 100% LED baseline. Roughly 20 to 30% of installed and projects out there are LED now, and we see this as a general trend for all new construction and renovations. It's represented by a decline in shipments of all conventional technology. Changes in the model then followed into the interior lighting power allowance. In general, when you see these slides, there is a gray bar at the bottom of each of the slides where the addendum to the standard can be found. So in this case, addendum BB made the modifications to the space by space power density allowances. It was an average LPD reduction of about 5%. There are roughly 140 different spaces within the space by space list. And if you just took an average of all the changes, that's where you come up with 5%. If you weight that by common or most area, that number might be different. The table over on the right, just as a sample of what you'll see, in the first column, you'll see 90.1 2016. And on the column on the right, you'll see 90.1 2019 values. You can see that for many of the spaces, the values decreased. In some cases, the values decreased a lot. For instance, a hotel lobby went from 1.06 watt per square foot to 0.51 watt per square foot. The single largest reason for that change is that the 2016 model assumed a fair amount of halogen and incandescent in there, whereas the 2019 changed that to an LED because good color quality LED sources are available and offset where we had previously used halogen sources. You'll see that some spaces had very little change. For instance, warehouse bulky medium objects only went from 0.35 to 0.33. You can also see that in a few places, values went up. Parking area interior, this is your parking garage. It went from 0.14 to 0.15. This is reflected because of a change related to the reflectance values. The space by space values all flow into what is known as the building area method. So if you are not interested in breaking down your entire building in each composite, in different space, you have a single value for a given building type. Again, because the space by space values were roughly a 5% average, the building area is also roughly a 5% reduction. This was modified in Addendum CG. Again, you can see the columns on the left are 2016 values, the columns on the right are the 2019 values. Some spaces did have some small changes, some spaces had some very large changes. Again, retail is an example, as well as hotel and motel. That was primarily because of technology changes from halogen to LED technology. Probably the largest change to the standard is this new compliance method, which is known as which is for simple buildings. Previously, I discussed the space by space method as well as the building area method. Those are two compliance methods. This is now a third one. It is only for office, school, and retail buildings up to 25,000 square feet. You may be thinking 25,000 square feet is not a lot of area. Turns out a number of the buildings, like 30 to 40% of buildings out there, are less than 25,000 square feet. So it actually it covers a lot of buildings. It is a single interior and exterior lighting power density target that covers the entire building, and the power allowances are lower than other methods. It is a simplified method, so therefore, in exchange of making it simple, you are giving up a little power. It does require occupancy lighting control in most spaces, with some exemption. And all power from all lights must be counted towards the interior lighting power allowance, no exemptions. This was modified as a result of Addendum BG. We'll see this now in action. So this is a screenshot from the standard. You'll see that this is for school buildings. Notice that you have all school places, classrooms, offices, conference rooms, gymnasiums, restrooms. These all have the same single value of 0.7. If you had looked at schools in either the whole building or the space by space, you would have seen that these spaces had different values. But again, the simplified method is a single power density value for all these spaces, similar to the building area method, but you are getting a reduced value again because as an offset to make it easier to comply with. That is your exchange. You'll see that there are some occupancy sensor requirements. There is no daylighting requirements because, again, the idea is the simplified method. Similarly, exterior has the same kind of concept. You get a slightly lower exterior lighting power allowance, and the other values for the different spaces are slightly lower than you would normally get. And again, some slightly different control requirements. Again, the concept of this is a simplified method meant for somewhat easier generic buildings, office, retail, and schools, as well as meant to be simplified, making it faster for compliance reasons. Moving on, a major update had to do with interior and exterior lighting wattage. We made some technical changes, such as replace the term luminaire with lighting equipment, as well as the term ballast and ballast driver. These were changes really to reflect changes in the lighting industry. Not everything is a luminaire anymore, as well as drivers for LEDs are much more common than ballast. We also split the section into 5 categories, one being line voltage for lighting equipment, another being line voltage for equipment with a remote baluster driver, track and plug busway, as well as low voltage track, and finally a new one for direct current low voltage lighting systems with flexible cabling for plug-in connection of lighting equipment and remote power supply. An example of this, but not as limited to it, is power over Ethernet lighting. The wattage of a DC low voltage system that employs flexible cabling for the plug-in connection of the equipment and a remote power supply shall be the maximum wattage of the power supply. So that's basically whatever that network switch is. If you're using PoE, that's your limit. However, if that switch, as noticed in the final bullet, is providing power to other devices, so imagine you have, again, a network switch and 3 of the ports are powering a light fixture, and 2 of the ports are powering other devices, you subtract the non-lighting equipment from the connected system. This was modified in Addendum AH. Addendum CV has to do with parking garage lighting control requirements. One of the things it did is it increased the stringency of setback in parking garages, both in the % reduction of the lighting as well as the timeout period. Over on the right, you'll see a comparison. In the first column is 90.1 2016. The second column on the right is 90.1 2019. The timeout period. So after no movement is detected, in 2016, 20 minutes had to pass before the lighting control enacted a command. Now it's 10 minutes. Similarly, in 2016, it was a 30% reduction was required, a minimum. Now it's a minimum of 50% reduction requirement. This primarily resulted because LEDs are more common, especially in parking garage applications, and they are available in both those ranges, whereas previous technologies had more limitations. We updated control requirements for transition lighting. Transition lighting is the lighting in an area as cars are leaving the parking garage into the main flow of traffic, and it has some different lighting requirements. We also updated continuous daylight dimming down to 50% required for luminaires within 20 feet of the wall opening. We also did add this new exemption for permanent architectural screens or architectural elements. The image on the right shows kind of a concept of what that is. We're seeing now parking garages and parking facilities with exterior screens to make them look more pleasing, and as a result, it's reducing some of the light coming into the space. So if the architectural element obstructs more than 50% of the opening, then there are some exemptions. Addendum AQ has to do with special applications and lighting controls. There really were no changes in terms of requirements in this section. What it did is it reorganized it to make it easier to understand and follow. So it clarified it. It put it in a tabular form here, where you have the number over on the left, description, whether or not it has to be controlled separately from the general lighting system as listed, and then any additional required controls, whether or not. So for instance, lighting specifically designed for use during medical or dental procedures, you'll see that yes, in addition to and controlled separately from general lighting, that's a requirement. Then you'll also see it also requires local controls. And it also points where to the applicable text you can find those, either, and that's indicated by the letter in the parenthetical after the section. That was done in Addendum AQ. We also made some daylighting control requirements via Addendum CW. The biggest one would be continuous daylight dimming required for all spaces. Previously, it was a step dimming requirement, and that was eliminated. Step dimming was very common when you had multi-level fluorescent systems and possibly with HID. But again, now that LED is becoming more common, and continuous daylight dimming just made more sense as an option. The low point output setting is for it to reduce the electric lighting in power in response to available daylight via continuous dimming to 20% or less. And then over there on the right, you can see with the definition of continuous dimming that it is continuous range from full output to a minimum set point, 20%, in imperceptible steps without flickering. We also added some text in there about how daylight dimming had to work with other controls. That's indicated in the bottom bullet. Thank you. Addendum CH also modified the daylighting zones. The first thing it did was it added a definition for daylight area under skylights in multi-story space. The easiest thing to think about in this is that it's a skylight in an atrium. So that's typically where you might see a multi-story space. The definition over there on the right describes what it means, that the daylight area under the skylights in multi-story spaces shall include the floors directly beneath the skylight and portions of the uppermost floor adjacent to the multi-story space that meets the criteria for daylight under skylights, where CH is the ceiling height of the uppermost floor. So that provides the information of how it's defined. We also added 2 figures for clarity. Sometimes words aren't as good as a diagram, and that's why we added 2 figures. Also, we added some exemptions related to primary side-lighted areas. Addendum CY also made some daylighting for side lighting requirements. We modified the side lighting requirements to clarify that the setback distance is a horizontal measurement. Previously it described a distance, but it didn't actually articulate that it was a horizontal from the vertical element of the fenestration. We also discussed added requirements in text that added natural objects as obstructions in addition to existing structures. You might have a hill or tree or some other natural object that might be causing some daylight issues, and that was included. Finally, we removed an error that inadvertently said an exact measurement of an obstruction. The text originally said it had to be a distance of twice as high. Now the problem is that what happens if it was just slightly more than twice or just slightly less than twice? It didn't comply. And so by removing the requirement that it had to be exactly twice as high, it made more sense for logic and more applicable. And that was made in Addendum CY. Finally, we made changes for selecting lighting power densities for non-typical exterior areas. What this means is that there's a table 94.2-2 that is a list of spaces. This might be parking areas, might be plazas, might be ATMs. There are some that are tradable, there are some that are non-tradable. From time to time, there are spaces that end users didn't feel that fell in this table, and there were questions about which one should they use. So as a result, the concept is if there's an applicable interior space that is actually in an exterior application, you would go look at table 961 and find its power density value. And then you would appropriately reduce it based on how you find it in the table. So an example of this might be outdoor seating in a sporting environment, if it's an open air, a walkway in a multi-story outdoor retail plaza where the walkway's exterior, that might be technically a mall concourse. So you might actually go look at the interior table, find the mall concourse value, and then what you do is you say, okay, I'm now using this in an exterior application, and then you find your lighting zone. So in this case, lighting zone 0, which is an intrinsically dark space, you don't get any allowance. But if this mall concourse happened to be in, let's say, lighting zones 2 or 3, if it was in lighting zone 2, you would only get 65% of the interior value. Again, the concept here is that this is an exterior application, so less light is needed, but there might be situations where the application or the space is not in the current table of 94.2, but it really is. So you go, again, look at the interior space, find the applicable thing, and then derate it by the applicable value in the table. This is all listed, it was all provided, and this was all done in Addendum T. And those are the major lighting changes in Standard 90.1 2019.
Welcome. Today I'm going to talk about the changes to the whole building performance paths in Standard 90.1 2019. But first, a little background. Standard 90.1 includes 2 whole building performance path options. Both use energy simulation to compare the energy cost of a proposed building design to the energy cost of a baseline building design. The first one, the energy cost budget, section 11, uses baseline systems and components that are the same as the proposed building, except their efficiency levels are back down to the current prescriptive requirements. We call that a dependent baseline. The second performance path, the performance rating method, or Appendix G, in that approach, the baseline systems and components are independent. Instead of being based on the on the proposed building design, they're based on the architectural program of the building and the location of the building. For example, the heating and cooling system is not based on the proposed heating and cooling system, but instead is independent based on the type of building and the location. In addition, the baseline is set at the efficiency values, the efficiency levels that are approximately equal to Standard 90.1 2004. So therefore, for compliance with the standard using the performance rating method, instead of just meeting the baseline, you need to beat it by a certain amount. We call that a stable baseline. The 2019 version of the standard included 23 addenda impacting ECB or Appendix G. Those impacting ECB fell into several categories. The first were changes to align with Appendix G where appropriate. So things that had been improved in Appendix G that were not improved in previous editions of the standard in ECB were now improved to catch up with Appendix G. There were some clarifications added, and then there were some updates to the baseline for consistency with the prescriptive requirements. So as the prescriptive requirements got more stringent, the baseline needed to be updated as well. In Appendix G, there were some cleanups of oversights and inconsistencies. There was a tightening of the definition of the baseline so that it was less ambiguous, and that led to support for consistent modeling and automation. So software that automates the baseline can do so with some rules that are more explicit. Addendum F provides some rules for the efficiency of HVAC systems when you combine thermal zones into larger thermal blocks. So Appendix G allows you to combine thermal zones for simplification into a thermal block if those thermal zones are similar enough. So that way you end up with a zone that is larger than the actual zones in your building. That can be problematic because HVAC equipment, the efficiency of HVAC equipment is dependent on the size of that equipment. And in general, larger capacity equipment is not as efficient as smaller equipment. So if you were to use the larger thermal block equipment efficiencies, it would make your baseline less stringent. So this addendum just clarifies that if you do combine thermal zones into a thermal block, you need to base the equipment size on the size of the equipment in the individual thermal zones, not in the combined thermal block. Addendum AL also deals with thermal zones and thermal blocks. It prescribes some requirements for when you can combine those thermal zones into a thermal block. And it tells you that you can only do that if the peak internal loads are similar. And it gives a definition for that by telling you that they need to be within 10 BTUs per hour per square foot from the average of all the other zones in the thermal block before you can combine them. It also makes some changes where it replaces the word spaces with HVAC zones, which is really more accurate description. This applies mostly to requirements for fan system operation. And then finally, it tells you that you need to use the lighting space by space method of establishing lighting power density instead of the lighting building area method, which is a broader method, less granular than the space by space method. There is an exception if you don't know the space type, because it could be future build out, something like a core and shell building, or where there's the tenant build out hasn't been done yet. In that case, you can use the building area method. Addendum D also deals with future building components. So if you've got not yet designed areas of your building, you're required to model it with the equipment meeting the prescriptive requirements of the current code. That way you're neither penalized or rewarded for that for those future building promises. Addendum E deals with service water heating systems. First, it tells you that you should not model piping losses. Pipe insulation is required. It's a mandatory requirement in 90.1, and you don't need to model them in your simulation. And second, it tells you that if you've got a combined service water heating and space heating system, the baseline should use two separate systems, not a combined system. Addendum L corrects an oversight where the fan power for systems 12 and 13 was not prescribed for the baseline in Appendix G. Systems 12 and 13 are single zone constant volume systems used for assembly spaces. We just left that out of the last version of the standard, so that was added. Addendum M deals with modeling infiltration. It specifies that if you don't do whole building air leakage testing, that if you just meet the prescriptive requirements for air leakage and air barrier, you need to assume in your proposed building that the air leakage, the infiltration is at 0.6 CFM per square feet exterior building area, and that is at a pressure differential of 50 pascals. It's just assumed that you meet that if you meet the prescriptive requirements, and then it sets the baseline infiltration rate at 1 CFM per square foot. Addendum R specifies that when your baseline building is required to use economizers, those economizers need to be modeled as integrated economizers. Economizers provide free cooling when the outside air temperature is cool enough to do that. And Integrated economizers means that the outside air can work in conjunction with mechanical cooling. So let's say it's a moderate temperature, maybe 60 degrees, and you can get some benefit from that cooler outside temperature, but it's not cold enough to provide all the cooling. The HVAC system has to work in conjunction with the economizer, has to be integrated with the economizer to provide that cooling. Addendum Y has some rules for how you size your baseline HVAC equipment. It clarifies that the oversizing that Appendix G specifies only applies to the heating and cooling coil capacities, not the airflow. I think Appendix G asks you to oversize your cooling coil by 15% and your heating coil by 25%, but you do not do that with the airflow as well. The second thing is it specifies that central plant capacities are based on coincident loads. That means the highest load happening at the same time, not adding up the highest loads that can occur at different times. It also specifies the design day conditions for your heating and cooling sizing. It uses 99.6% dry bulb for heating and 1% dry bulb and wet bulb for cooling design temperatures. It also specifies the internal gains to be used in the sizing runs. It tells you for your heating sizing that you set all your internal gains to the lowest hourly value that you use in the simulation. And for cooling, you set it to the highest annual value that you use in the simulation. That's a conservative approach. It does give an exception for residential occupancies, and instead of using the highest cooling value, the highest internal gain for cooling, you use the most frequent internal gain for cooling. And that's specified in the ASHRAE Handbook of Fundamentals, and that's why that is done. Addendum S deals with renewable energy trade-offs, and it limits the amount of trade-off you could have against energy efficiency for renewable energy, but only when it's used for compliance with the standard. If you're going beyond the minimum requirements of the standard, you can get as much credit for renewable energy as you put in your building, but if you're using it trading off against efficiency for minimum compliance, you're only allowed to get 5% of the baseline building energy cost as credit from that renewable energy system. And there's some formulas here. I'm not going to go through the details of the formula, but there's a formula that adjusts your performance cost index based on the amount of renewable energy that you have in the building to make sure that you are still lower than the performance cost index target, which is how compliance is shown in Appendix G. Addendum AG established a methodology for getting credit for automatic receptacle controls. 90.1 has some requirements for receptacles to be controlled by based on occupancy. But if you go beyond the minimum requirements and you install those controls where they're not needed, prior to this addendum, there was no way to get credit for that in Appendix G, but now you can with this change. Addendum AK was really a simplification. There was some solar heat gain coefficient and visible transmittance requirements for fenestration that were not specified directly in Appendix G. Instead, it pointed you to some calculations in another part of Standard 90.1. And now that's simplified by just including tables that have the required visible transmittance and SHGC for your baseline fenestration. Two addenda, BT and CI, update the building performance factors in Standard 90.1. The building performance factors are used to establish compliance with the standard. They adjust the performance cost index target of your building based on the building type and climate zone. And those building performance factors basically represent the ratio of the energy cost of a building compliant with Standard 90.1 to the energy cost of a building compliant with the stable baseline, the Standard 90.1 2004 baseline. So obviously, as the standard gets more stringent with each year, those building performance factors get updated as the baseline stringency stays the same. So that's a table that needs to be updated with every new version of the standard. Addendum AZ provides some rules for commercial refrigeration system modeling. It basically tells you that if you have a proposed building refrigeration system that's rated in accordance with the HRI standard 1200, the energy use should be modeled in accordance with that rating standard. Pretty basic. Addendum BA deals with getting credit when the values of the baseline system are not specifically prescribed in Appendix G. There are some cases where you're told you're allowed to get credit if you go beyond standard practice, but it doesn't really tell you what standard practice is. Some examples are service water heating loads, cooking equipment, laboratory equipment, and it basically gives you the rules it tells you are that If the baseline values are not prescribed, you first look in the prescriptive requirements of sections 5 through 10, and if there are prescriptive requirements, you use those in the baseline. And if there aren't, you look at other codes or standards that are applicable to the building, such as the plumbing code, the ventilation code, or the occupational health and safety code. Addenda AR and BU make some minor table and language cleanup changes. It adds the words performance rating method to the titles of some of the tables that are in Appendix G, just so that it's not confusing to users. There were some redundant footnotes that were left in some tables that are removed. There were some leftover baseline references to proposed building heating source that were really not applicable, since the baseline is independent from the proposed heating source. There were some places that changed the word spaces to zones in several instances, which is really more accurate. The term process loads was changed to internal gains, so that when we're looking at sizing equipment, we don't just look at the gains from process loads, we look at all internal gains, including lighting and the gains from people in a space. And then it fixed some section headings that had the wrong system numbers. As more systems were added to Appendix G, the numbering changed, and some of those tables did not catch that in previous editions. Addendum AT deals with recharging and refueling vehicles. It basically tells you that if you're using energy to recharge or refuel a vehicle that's used off-site, you don't calculate that in the proposed, or you don't include that in the proposed building energy costs. So for example, if you've got an electric vehicle charging station that workers are using to charge their cars, that they're commuting back and forth from work, you don't count that in your calculations. But if it's an on-site vehicle, let's say a forklift in a warehouse that's being charged, you would count it. Addendum BK deals with on-site electricity generation systems, things like generators, combined heat and power, or fuel cells. It tells you that if you have that in your proposed building, that kind of generation in your proposed building, the baseline has the same generation, except the baseline does not include any recovered heat from that system. So if you're recovering heat from a CHP system, for example, you get credit for that by having it in your proposed design, but not in your baseline. Addendum CJ makes various changes to the lighting requirements in ECB and Appendix G. First, in ECB, it tells you that if you've got dwelling units, guest rooms, or other spaces that will use plug-in lighting and the lighting's not shown on the plans, the baseline lighting power has to equal the proposed lighting power. So that means you're not credited or penalized for that. It sets the baseline lighting power for dwelling units at 0.6 watts per square feet. It also tells you that if you've got an existing lighting system, like in an alteration, or you've got a space that doesn't have a lighting design, like a future tenant build-out, your baseline lighting power equals your proposed lighting power. Once again, you're not penalized or rewarded in that instance. And then it also tells you that when you're doing, for your daylighting calculations, you need to treat primary, secondary, and top-lit daylight areas separately. The amount of savings that occurs in each of those areas is different. You can't combine them all into one daylighting zone and estimate the savings. You need to treat those separately. Primary side-lit daylight areas are those right next to windows. Secondary are further away, and top-lit are those under skylights. In Appendix G, it has some rules for dwelling units and guest rooms that are served with plug-in lighting not shown on the plans. It prescribes that in your proposed lighting design, you should assume there's 0.6 watts per square foot, or as designed, whichever is greater. So if you show some fixtures in your proposed design, but it's less than 0.6 watts per square foot, you have to assume that it will be 0.6 watts per square foot. The rest will be made up with plug-in lighting. You can show something different than that. There's an exception. If you've got fixtures with high efficacy and you can demonstrate that they will result in a lighting power less than 0.6 watts per square foot, and you will provide the same illumination as you would have with a 6 watt per square foot system that gave proper illumination, you can get credit. And then finally, it sets baseline lighting power for dwelling units in Appendix G at 1.07 watts per square foot. Addendum BI deals with requirements to test the simulation program in accordance with ASHRAE Standard 140. Appendix G and ECB have long required that simulation programs be tested in accordance with 140, but it ended right there. Only that the simulation program had to be tested. There was no requirements for results or there was no pass-fail or anything like that. There still is not a pass-fail, but we have added some new requirements. Among those, you have to post the results on, or the software developer has to post the results on a public website, along with the results of reference software, and there's reference software in appendices to Standard 140, so that way you can compare the simulation software that you're using to the reference software. If that simulation program results fall outside of the reference results, there are some forms that need to be filled out and posted as well. The modeler needs to provide a link that they give to the building official with their modeling submittal to those results. But as I said, there still is no pass-fail requirement. Addendum Z has to do with how you model the efficiency of packaged HVAC equipment. Most simulation programs require you to input the performance of the HVAC system without the impact of the indoor fan unit on it. We call that the COP, or the coefficient of performance, no fan. And there was a formula that was used to adjust the rated efficiency of the equipment to a COP no fan efficiency for input in the model. That formula is shown here, and in that formula is a term Q, which represents the capacity of the HVAC equipment. The change that was made is that now the Q term tops out at 63 tons. Basically, if you have equipment larger than 63 tons, the Q term stays at 63 tons. That just makes the equation more accurate. In Appendix G, you no longer even need to use that equation. Instead, there's some tables added to Appendix G that have the COP no fan heating and cooling efficiency to input directly into the model for simplification. Addendum S applies to renewable energy trade-offs in both Appendix G and ECB. Previously, you were not allowed to get any credit for a renewable energy system if it was not owned, if the renewable energy system was not owned by the building owner. Now there are some other options. If the building owner has signed a lease for a minimum of 15 years to lease that system, you can get credit for it. Or if the owner has signed a power purchase agreement to purchase the renewable energy system, you can get credit for it as well. This last addendum, Addendum CL, applies to ECB only, and it makes a bunch of changes to ECB to help better align it with Appendix G. Appendix G has probably been more scrutinized over the last several editions of 90.1, and there were some changes made to it that were not picked up in ECB, and this addendum is an attempt to do that. It just updates the definition of a simulation program to include both the simulation engine and the GUI. It requires a full 8,760 hour simulation, so every hour of the year instead of only 1,400 hours. It updates some documentation and submittal requirements to be consistent with Appendix G. It adds requirements that the weather files include solar radiation, wind speed, and wind direction. It adds some requirements for exceptional calculations. Those are calculations that are done outside of the simulation program. There's some sensitivity analysis and documentation that's required. It adds some rules for equipment sizing that's similar to those that we talked about in Appendix G earlier. It allows credit for demand-controlled ventilation. That's reduction of the outdoor air ventilation when the building is not fully occupied. It sets some requirements for baseline system airflow, fan sizing, some requirements for fan temperature and humidity schedules. As we discussed before, it also specifies that piping losses should not be modeled like they were not in Appendix G, and then a few other minor changes for cleanup and consistency.
Hello, I'm Reed Hart with Pacific Northwest National Labs, here to talk to you today about commissioning changes in Standard 90.1 2019, and I had the privilege of being the chair of the commissioning working group for the last 5 years. So today we'll talk about why commissioning in 90.1, why we made some changes, and also talk about the actual requirements in the standard. So why commissioning? Why would we want to be prescribing that in 90.1, which is an energy efficiency standard? Well, first of all, we assume that all the field assemblies and controls work, but do they? Actual field studies of commissioning have found that commissioning saves in new buildings 7 to 30%, or a median of 13% of energy use, and that's because things were not working that the commissioning study found and fixed. A broad scope study of both new and retro commissioning found pretty substantial savings. You can see the graph on the right, the bubbles, the size represents how much savings per building type, and office as an example is 22% savings. And you can see that the paybacks of the commissioning effort itself range from 1 to 3 years. So if we dig a little deeper into this study and look with a focus on new buildings, 90.1 mostly applies to new buildings, although it does include renovations and retrofits. There were 82 new buildings in the study across 15 states, and when we look at the median savings and cost in new construction, the median payback was 4.2 years, and that certainly meets 90.1's cost effectiveness criteria. Now this is based on a pretty broad study of almost 9 million square feet of building area, and in those buildings, more than 3,500 deficiencies were found, or 43 per building. So it does indicate that there is a strong benefit to bringing commissioning to buildings and making sure things are working as the new building gets launched. This chart shows commissioning across different code efforts. If we start actually over on the right, for the last few cycles, 2015 and forward, the IECC has had a major revamp of their commissioning description and some pretty clear idea of when you apply and don't apply commissioning. 189.1 put in a new commissioning revision. They did have commissioning requirements, but they made them much more clear and included an informative appendix. And in 2019, we tried to follow as much as possible the 189.1 lead and model our structure with requirements as well as informative information to provide the best mix of information. And we'll get into the differences between 2016 and 2019 as we move forward. Now you might ask, why do we need commissioning of energy efficiency requirements? After all, commissioning is often done on many building types throughout the industry. Well, we had two interesting questions a few years ago. We were looking at commissioning and building controls and how efficient controls got implemented, and we found that talking to 10 different commissioning agencies across the country, that 6 out of 10 of them did not include verification of efficiency requirements in their typical commissioning scope. And also, the same number, 6 out of 10, found that the plans and specifications they were used to looking at did not really include clear language around the efficiency requirements. So there's a real need to bring that up and get some focus in the energy efficiency area with the building construction industry. So to conclude why we have a modification of the commissioning for 90.1, there is ASHRAE Standard 202 out there. It defines the commissioning process, but it's still up to the owner and the commissioning agent to figure out what they're going to focus their commissioning efforts on. It doesn't tell you what to do. Guideline 0 and 1.1 and other guidelines tell you how to test different controls, but again, they don't tell you what to do. 90.1 has very specific items related to energy efficiency, both on the control side and the field assembly side, that they want to have tested and verified to know that they're going to provide the savings that is predicted. And in the industry, commissioning, verification, and testing is now accepted. It's not a new thing. It's required as a base in the LEED program, whereas it used to be in advanced. It's required on all federal projects, and it's found to be cost effective based on field studies in the last 2 decades. So what are we going to look at for 90.1 testing and commissioning requirements? Well, if we roll back to 2016 and we see what was in that document, we did have some functional performance testing for lighting, HVAC, an optional path and envelope, and we had envelope verification requirements. There was documentation required for those, although the documentation was varied depending upon the discipline, and it wasn't all brought into one format or place. In the HVAC area, there was commissioning required on buildings over 50,000 square feet, and there was some indication of testing requirements for all controls generally, but these statements were very general and didn't provide a lot of detail. As we move forward into 2019, what we've done is pull together a uniform set of documentation requirements so that everything falls under the same umbrella. We put that up in Chapter 4, so remember to look to Chapter 4 to see where the actual commissioning and verification testing outline is. We added some functional testing for power, service, water, heat, and pressure pumping and some of the other areas. And then we did set up some structure of when do we require testing pretty much in all cases, and then when we add the additional steps of commissioning, and we'll get to that in a minute. So a lot of detail here, but if we look on the left, we see we had the functional performance testing and envelope HVAC and lighting. And now over on the right, we've added testing for service hot water controls, power system controls, and other controls, as well as indicating in the performance testing, the performance paths, if you had some new technologies that were not mentioned in the prescriptive part of the standard, you would be required to verify that those are operating properly too. But the most important thing is the top of that list, where we put in some cross-discipline consistent requirements. There's verification and testing and commissioning provider definitions, which indicate that those folks need to be qualified, and they also need to have at least a quasi-independent situation where they are not directly involved in the construction or the design of the building. And again, we have clear and standard documentation. We'll get into more detail, and the main thrust of it is moved to Section 4, with each of the individual discipline or area sections having commissioning and functional testing called out in the same location so that you could clearly see what's going on. So to put it in a nutshell, we started with the verification and functioning performance testing details that were already in the standard. We added some new items that had not previously been covered. For 2019, we added some more clarity about how you would document those things, what the definition of verification testing providers are, and that there would be provision in the construction documents that those tests could be properly maintained and executed. And then for buildings where it would be required, we talked about a commissioning process that would focus on the elements in Standard 90.1. And the commissioning process would include the verification and testing that we had already talked about. It's not a separate effort. It is intended to bring everything together into one overall process. So where do we require things? We looked at it, wanted to make the punishment fit the crime, so to speak. We wanted to look at where more complex systems were involved to move through that commissioning process. So basically, buildings under 10,000 square feet, which matches up with 189.1, did not require commissioning at all. And in addition, buildings that followed the simple HVAC path, which can include up to 25,000 square foot buildings, those did not have to add on the commissioning requirements. And warehouses as well, no matter what the size, were also accepted from the commissioning. So that means that 80% of the buildings in the country do not have to follow the commissioning path, but all buildings are required to test the things that need testing in the building. So then complex buildings under 50,000 square feet, complex as far as HVAC types of systems, and all buildings over 50,000 square feet then would follow the commissioning path. So what is commissioning? Well, it specifically includes all that verification and testing we've been talking about, same as required for the smaller buildings. It also includes verification that the building meets 90.1 standard. Now, the smaller buildings can usually do that just with a ComCheck software run out. They don't have the more complicated controls that require a little more expert eye to verify that they're operating. And there is a requirement for the commissioning plan and reporting to be done following the general process in Standard 202. And there's distinct verification and commissioning discipline sections throughout the standard that can add additional things, although at this point they pretty much point to pulling in the verification that is already required. So the updates were to develop a consistent approach across the technical sections, so we have the same type of formatting. It doesn't look completely different from lighting than it does from HVAC, much easier on the building official. There's sections on general functional testing and commissioning, definitions, requirements, that sort of thing up in section 4. And then the 90.1 commissioning requirements and format were coordinated with standards 189.1 and 202 so that there was some parallelness, so a building going through 90.1 and 189 would be following similar processes. The design review was included when commissioning is required, and cost effectiveness for that was justified based on a pretty detailed study done for Title 24. And overall, the commissioning also includes a review of 90.1 compliance. So what documentation is required? We need a commissioning plan. We need to see that information included in the specifications. So there's a design review report that also double checks that we've got that 90.1 compliance. Much cheaper to make changes at the design stage than it is later. The verification and functional performance testing reports get included, and then a preliminary commissioning report that will include everything that you can find out about up until the occupancy permit time or near that time, and it would also include what additional tests should be done later to lay out what the final commissioning report would look like. And just a point of clarification, Standard 202 is great for laying out the commissioning process, commissioning plan, and setting up a full, complete process to go through the commissioning approach. However, it's still up to the owner what to include in the plan. 90.1 calls for items that really need to be looked at related to 90.1 as far as energy efficiency, and wants to also see a design review for compliance with 90.1. So in conclusion, beyond what 90.1 specifically calls for, there could be additional items that want to be commissioned that the owner wants to include in the scope, and that is a good idea, but it's really not the purview of 90.1, so we didn't necessarily require all those things. And there is an informative appendix, Appendix H, that lays out the typical commissioning process and then shows you where are there requirements related to that process in 90.1. So we have a good tie back, and it also shows where there are things that are not necessarily required. Also in this informative appendix, you've got a multi-page table that lists all the subsections of the standard that have items that probably should be commissioned. So this provides a good starting point for the commissioning agent and the owner to pull together their scope of work as far as what things either need to be verified or tested related to 90.1. Well, I hope that gives you a clear idea of what changes we brought with commissioning, and thanks for your time and attention.
So I know that we've had some questions come in, although I haven't been able to keep a check on all of them. So I think what I'll do is I will start with Drake to see if he has any questions that have come in on the overview of 90.1 2019 and or any other comments that he would like to make. Drake, are you on with us?
I am.
Great. Did you have any questions that came in?
There weren't any general questions. There was one about the addendum on title, purpose, and scope relating to site. It's still moving through the process, and so I don't want to get into too much detail on that. I will say that it is addendum. Excuse me. It's addendum CB, Charlie Bravo. So it is still going through comment stage. It'll go back out for public review after, I'm sure, another independent substantive change. So look for that. And please don't hesitate to comment on it. We want to make sure we get this right. And that's the process we go through, is making absolutely sure that you have opportunities. Everybody at large, if you will, the entire built environment community has an opportunity to comment on these addenda. Thank you.
Great, thanks, Drake. Len, did you have any questions that came in on the envelope?
Yes, so it looked like there were two questions. One was, are there any changes in regards to the envelope assembly? And primarily the criteria changes were about the windows, when we went through those window slides for the SHGC and U factor of windows, and then the material. The other question was, are there standards for industrial buildings? And that's sort of a general question. Yes, industrial buildings would be considered commercial buildings, and as you look through the standard, they're primarily semi-heated buildings, and so in many cases those are exempt because the mechanical systems are really simple, and they usually tend not to have a lot of cooling, so they're basically boxes. So depending on the type of industrial building, they would be exempt or limited requirements. And then the one last question, and this is a little bit about infiltration modeling, it was asked in relation to Appendix G. CFM is per envelope area, so it's not square foot of building, it's the square foot of the above grade building envelope, or the building envelope area, which does include below grade walls. So if you have a basement, you get to include that square footage of those walls. So it's roof, walls, roof and walls, above grade and below grade walls. That's how you sort of calculate the area when we talk about CFM per square foot. So those are the three that I saw.
Okay, great, Len. Thanks much. So we'll move on to Jeff. Did you have any questions on mechanical?
I think I had 5. And 3 of them I think will be quite quick, and then if you gong me, you gong me. But one was more a comment than a question. I think on my slideshow, I said that we referenced 90.4-2019. I think actually at the time that we finished work on 90.1-2019, 90.4-2016 was the current standard. Although I did check in the back of the standard, and there is no year listed. 90.4 doesn't appear, at least in the IP version that went out originally, as one of our referenced standards. But I believe 2016 is the correct answer for that. So I also had a question about whether we did an economic analysis for the ERV and non-transient spaces. And yes, we did. I think it was gone over at 2 different in-person meetings. And if you have additional questions about that, we could definitely get you involved with the person who did most of the analysis on that. I also got a comment from one of the other committee members that today you can get small ERVs that would replace the bathroom exhaust and help to limit the first cost in that. But if you have more questions about the economics, get a hold of us. Also, I negligently forgot to include that after 1/1/2023, a lot of air conditioning units that are under 65,000 BTUs in capacity will be rated in SCER2, EER2, or HFPF2 for heat pumps, and referencing the appropriate 2023 AHRI standards. This is probably mostly of interest to manufacturers, but it gives them 3 years to make sure their products are all rated correctly and so forth. So you kind of try to lead the target so manufacturers don't get caught off balance with these type things. For you engineers, it just means you'll have to get your specs updated to reference the right standard, or somebody might tell you that you're out of date. although they still won't be able to sell something that doesn't comply. Let's see here. I'm going to do my other short ones first. I had a question about FEI and fan arrays. And basically, the efficiency required for fan arrays would be essentially the same as if it was one big fan. The only exception is because the individual motors are smaller, the motor efficiency part of the wire to air will be a little bit different. So if you have 8 fans in a fan array compared to one big fan, you might get a 2% credit or something like that because the motors are smaller motors with lower efficiency requirements. I had a question about ventilation shutoff for VAV and other large systems. I've not had any trouble with that. We've just been waiting for 62.1 to allow it. I mean, going all the way to shutoff, I find is pretty easy. You just close the VAV damper. Or if you're doing something like chilled beam, you will need a damper. And you might want a pressure independent damper. There's some pretty inexpensive units of that type on the market. But basically, if there's no motion sensed, and usually it's hooked in with the lighting sensors, you close the VAV box unless the temperature gets out of range. Usually I have more trouble with us maintaining the 20% minimum that 90.1 requires these days when you are occupied. And I think that's been clarified to say that you can bounce on and off the stop. For example, if your VAV box pressure controller DP sensor for the box doesn't go low enough to measure 20% flow, it only goes low enough to say like 40%. You can spend half your time at 0 and half your time at 40%, and it allows you to bump back and forth between those. There was also a question whether the CFM per person or per square foot have changed. 90.1 does not really mandate those. Those come out of 62 or 170 or your applicable building code. Okay, so I've got one last one if I've got time, and this was about embedded fans. I didn't spend a whole lot of time talking about the exceptions to them. There are several that I didn't mention. We added a definition for embedded fans, and it's a fan that's part of a manufactured assembly where the assembly includes functions other than air movement. The 2013 and 2016 editions of 90.1 pretty much included that, but this clarifies the wording to make it more understandable. There's also an exception for fans that are not embedded fans that have a motor nameplate less than 1 horsepower. In embedded fans with a nameplate up to 5 horsepower. Embedded fans that are part of equipment listed in section 6.4.1.1, which then refers to a bunch of tables 6.8.1-1 through 20. And this is what we sometimes call ASHRAE equipment, which is equipment that ASHRAE writes the efficiency standard for, as opposed to some equipment DOE is the main body that writes those standard. Embedded fans also do include equipment bearing a third-party certified seal for air or energy performance of the equipment package. So we don't actually require that AMCA is the only thing you can use. You can do an independently certified thing. Let's see here. And embedded fans and packaged equipment, the reason they're exempt, and I think I mentioned this a little bit, is because the total efficiency of the unit's already included in the rating, and we'd kind of be double counting the fan if we did that. There are a few other exceptions you probably won't run into real often. Fans that operate above 482 degrees Fahrenheit, fans in an explosive environment, and well, and one you will see is fans outside the scope of AMCA 208. And I think that's all the questions I had.
Okay, great, Jeff. Thanks much. Okay, Michael Meyer, I know you have a few to answer on lighting.
Thank you. I think one of the first one is, can we explain why the lighting power density has gone up for parking garages from 2016 to 2019? It's a great question. Parking garages is not the only value that went up. There are a few others. The primary reason is that the model which develops the values had a wholesale review. Every input was reviewed. And during that review process, we discovered that the previous models only considered really 2 typical reflectance scenarios. So in lighting, we talk about reflectance values being the ceiling, the wall, and the floor. 80, 50, 20 is a very common value. The previous model had 70, 50-20, and 50-30-20, meaning that industrial spaces had a 50% reflective ceiling, a 30% reflective wall, and a 20% reflective floor. In the process of our review, we looked at some other energy efficiency programs and data, and they actually said that parking garages, they actually used an analysis of 30-0-10, meaning the ceiling 30% reflective, 0% reflective wall, partially because many parking garages are open for ventilation and other reasons, and a 10% because they're concrete. So because the reflectance value changed, or had some guidance, and because the values became darker, the power density increased, because when your materials are darker, more light's absorbed than reflected, thus increasing your power density. I would say of the values, 140 roughly in the table, I would say in the neighborhood of 10 increased, primarily because of reflectance values when we reviewed the model inputs. Another example is a lobby, or parts of lobbies for auditoriums and things like that. Again, these tend to be darker spaces for those reasons. So those were one reason why the change made. Another person asked a question about did the lumen value change? And I think the question what they're asking is, did the light level change? And yes, that also changed. We did a review of every input we have for the model. We compared it to Illuminating Engineering Society guidance, and in some cases, previous values may have been, let's say, 30-foot candles, and the model may have only been doing 24-foot candles, or vice versa, it may have been doing 35-foot candles. So we recalibrated the model based on guidance from the Illuminating Engineering Society. The Illuminating Society is a co-organizer of the standard, as well as they periodically update their requirements and recommendations. So it is good to always go back to it. So those two inputs can directly change things independent of the efficiency of any of your technologies. A very astute listener did catch a question there about continuous dimming. No, the daylight dimming is not required. The continuous daylight dimming is not required in all spaces. It is required in spaces where there is what we call a daylight zone, and those can be side light daylighted zones or top lighted daylight zones, depending on where the fenestration is. And so yes, the question is that based on the definitions provided within the standard, you then use daylight dimming, and it needs to be continuous only when there is a daylight section, not in general everywhere. So it's a good question. Only in daylight spaces do you need, only in spaces with available daylight do you need to do continuous daylight dimming. And again, that's all defined with great graphics and a fair amount of information in the standard. I'll answer one more. I'm always conscious of time, so that someone else can do it. Someone commented about LED lighting and street lights in Chicago, parking garages. I thought the bulbs seemed very bright and the distribution doesn't seem as good. I mean, first, it's really hard to be indicative of any one light source. Optics comes down to good optical control. First, all light sources can be glary or bright. That's a contrast ratio. So if the fixture is not either designed properly or you just look straight up at it, I promise you it'll appear very bright. Current street lights that are not LED also appear very bright when you look straight up at them. So that is actually not uncommon. Distribution matters. Just because a light source fixture is LED doesn't mean it is better than another source. I've seen some bad installations where someone put in a poorly designed distribution. Just because it's LED doesn't mean that the optics are designed right. You really need to look at the LED is really just the efficiency of the source, and it does allow for some better optical control. But if you don't have a product designer who really knows optics, that can fail right there. So ultimately, lighting comes down to what are you trying to light, what are your lighting needs, and your light source and your distribution all matter, and there's no one single answer for any source type or any answer. So I can understand the concerns you're seeing, but ultimately work with your site is what I would recommend. I'll turn over the rest of the time for other questions.
All right, thanks, Michael. We'll turn to Michael Rosenberg.
Can you guys hear me?
Yes.
Okay. I'll follow up on the one that Len answered about infiltration. So Len pointed out that it's the numbers in Appendix G are about the pressure boundary of the building, the the walls, underground floor, underground walls, roof. I just wanted to point out that there are some formulas in Appendix G if your simulation program takes an input of infiltration per area of square foot or per floor area that will help you do those calculations. There's another one about the building area method and the space by space method. Can you mix those two in your proposed and baseline building? And the answer is no. In general, you have to use the space by space method in both cases unless you know what the spaces are going to be in your proposed building, because it's a future build out like a tenant improvement. In that case, use the building area method, and you have to use that in the baseline as well. What about a carbon metric, somebody asked. So the performance paths in Appendix G use energy cost as the metric. There have been some states, New York, Washington State, Washington, D.C., that have been looking at other metrics for the performance path, and we've recognized that in 90.1. And I think this year we're going to maybe, or this cycle, we're going to maybe look into an appendix that would give some guidance for those jurisdictions that want to use a metric other than cost, carbon or source energy are two of the main ones, on how they could do that with the Appendix G approach. Trying to, sorry, there's a lot of questions here. I got to page down a little and see if there's another one. Somebody asked about, okay, large assembly buildings, the systems, system 12 and 13, I believe it is, that apply to large assembly buildings. They're single zone, constant volume systems. They're asking if that applies to the whole building. The answer is that Appendix G gives you some explicit recommendations for spaces within the building area type that may be different because of different loads or schedules. So if you've got some ancillary spaces around the large assembly spaces in a public assembly in an assembly building, chances are that they will be required to use a different system, typically one of the packaged single zone systems, in addition to the large constant air volume single zone system for the assembly space. I believe that might be the last one I see here.
And Reed, we'll turn it over to you for the last of our questions.
Okay, I want to answer one first on economics, not commissioning, since I'm also on the economics working group on 90.1. And there was a question, what simple payback do we use? Well, we actually don't use a simple payback, although it's part of the functional process. We, every 3 years, we look at reasonable commercial discount rates, loan rates. We look at national average energy prices and use EIA, Energy Administration projections for energy, and come up with what's called a scalar threshold or target. And so that varies by the equipment life or the measure life that you're looking at. So for instance, if I've got equipment that has a 20-year measure life, then I have to meet a simple payback of about 15 years. So, and that number is slightly varied for the heating or natural gas side versus the cooling or electrical side, and you weight the savings to come up with the exact payback target. So if the payback is under that target, the simple payback, then you meet it. All right, on to commissioning. There was a question whether the study I cited was available. Yes, if you just go in and search the name Mills, M-I-L-L-S, commissioning, and LB&L, you will find many studies by Mr. Mills over the years, you know, that built on each other and had the commissioning. And if you look at the slides, the full title of the study is in there as well. There was a question about simple buildings and a 50,000 square foot cutoff. So just to clarify, the simple HVAC process is limited at 25,000 square feet. So anything over 25,000 square feet will fall into commissioning. The reason I laid it out that way is the CBEX data about how many buildings are in which category has a break off at 50,000, just so we can see what that was. And early on, we're considering whether to limit design commissioning to above 50,000, but we ended up making the same cut that we did for general commissioning. commissioning the envelope, there was a question about are there changes in those requirements. The actual requirements have stayed the same. You either have to do an on-site verification that everything's going together correctly in the field when the envelope is accessible for inspection, or you have to do a whole building test, as Len talked about, based on air pressure in the building. So there's not really a change in the requirement. The only difference is that it is structured. Now, I would point out one difference in envelope is they do require third-party independent inspection, whereas for many of the other simple things, you could have someone in the firm. So a design build contractor could have a separate testing person in their firm who's not involved in the installation or the design. And I think that's it for commissioning.
All right, great. Thanks, Reed. So we've made it through, everybody, and we're just a minute or two over time. So I wanted to thank all of you for attending, and I'd like to thank also all our speakers for their time and attention. And everybody, thanks again for participating in today's webinar that was brought to you by the U.S. Department of Energy's Building Energy Codes program.